3.1. We're going to go back to, technically, I would say some of this is elementary vocab for you. Okay, these are words you've seen. I'm not saying they're words you remember, but they're words you've seen. Fair enough? Mm-hmm. Okay, so real numbers. Give me thoughts here.
1, 2, 3.
Okay, more than just that. I mean, I agree. Those are real numbers, but give me more.
6, 7, 8, 9. Not imaginary, like I.
Okay, there we go. There we go. Not imaginary.
Is it not a fraction? Or
they can be fractions.
Or like
Is it 0 to infinity?
It can't be negative. I know that.
Mm-hmm.
Plus or minus.
They can be.
Minus 0 to infinity.
Okay, negative infinity to infinity.
Kind of in a way. I don't know if I'd use the infinities, but so my definition I have written here is any number that can be written as a decimal. Okay, so and I heard the not imaginary. That is a good way to put it too. It's everything except the imaginary numbers. Remember, we learned imaginaries last year. It's everything but those. Okay, it's also going to include all these other subheadings. Everything we're getting ready to talk about: rationals, integers, natural, wholes, irrationals. It's everything there. Okay, so any number that can be written as a decimal is what I officially put. As I said, including something along the lines of the non-imaginary numbers includes everything, it also includes everything below. So, on my paper, this fit better. Never fits quite the same on the board. You guys know that. So when I say anything that can be written as a decimal, that includes positives, that includes negatives, that includes fractions, that includes decimals. It includes everything. Okay? So I guess if you want, you could also put non-imaginary numbers. You guys know my number sign, yes? It's not a pound sign in my classroom. It's a number sign, right? We've had that discussion, I'm guessing. Mm-hmm. If not, you're getting it now. So, okay. What do you remember about rational numbers?
It can't be.
Are those the ones that, like, the decimal form isn't repeating? Or like it's the one where it...
Actually, the decimal form could be repeating.
They're positive.
And?
Negative. Think about
and negative here. Okay. Any number that can be written or expressed as a fraction or ratio. Okay. Officially, the mathematical word I should say is ratio. Fraction is what I often say. So any number that can be expressed or written as a fraction or ratio. Now, repeating decimals can be written as fractions. Okay. Terminating decimals, so decimals that end, can be written as fractions. Okay. So, any number that can be expressed or written as a, and I don't care if you use the word fraction or ratio. Okay. I do have in my notes, basically it's anything that can be written of the form A over B, as long as B is not, what can B not be in that denominator? 0. Yep. Okay. Okay. So, and rational numbers, they are a real number. Okay. What about integers?
Are those the whole numbers?
No, they can be negative.
Partially.
Yeah. Oh, they can be
Like positive and negative whole numbers?
There we go. Put it all together. Positive and negative whole numbers. So basically it's the whole numbers. 0, 1, 2, 3, 4, so on and so forth, but also their negative counterparts. Okay, now, I don't really put this one in words. I just kind of make an example and I use a brace set and I do dot, dot, dot. -3, comma -2, comma -1, 0, 1, 2, 3, dot, dot, dot. If you want to put it in words, it's whole numbers and their opposites, is what you could say there. Okay? And integers is one of those words, as a math student, you need to be familiar with because it'll pop up in directions or a word problem or something. So you need to remember what they mean when they say integers. Okay? What about natural numbers?
Can it also be negative? Maybe.
Nope.
Nope. Okay.
If you're a preschooler, how do you count?
1, 2, 3.
Those are your natural numbers.
1,
Okay.
2, 3, 4.
It comes natural.
So on and so forth.
Okay.
I mean, technically, they go on forever, so past where a preschooler would count, but they also have the name called your counting numbers, which kind of gives you, an idea. They're called the counting numbers as well, but they start at 1 because that's where you start counting. 2, 3, 4, 5, however far you want to list, so on and so forth. Okay, so a good way to remember natural numbers, it's your counting numbers. Think how you count without getting all goofy and weird on me. Okay, what are your whole numbers? The only difference is it's your counting numbers or your natural numbers, but you include 0. Okay, so whole numbers, you guys know whole numbers. They have to be positive, but it's the whole numbers. No fractions, no decimals. So it starts 0. 1, 2, 3, 4, however far you want to list. Okay, and your rational numbers. What do you remember about your rational numbers?
That'd be like square root of 7 or something.
Okay. Why is square root of 7 irrational?
It's not perfect. Or,
As in not a perfect square?
yeah.
I was like, what do you mean not perfect? Okay, not a perfect square, right? If it's not a perfect square, what kind of decimal is it going to be?
Right.
It's going to be on and on and on and not repeating, right? It's going to be, if I use my non-mathematical words, a big, long, messy decimal, right? That's what, to me, irrational numbers are big, long, messy decimals.
It's like pi.
Pi is the irrational number. Okay? So I have it written in my notes as decimals that do not end and do not repeat.
Would an imaginary number, like I or something, fall under that category?
No, because I is the square root of -1.
Okay.
An irrational number has to be a real number.
Okay.
Okay? So I'm going to write this as decimals that do not end and do not repeat. The two good examples that I've heard, pi and square root of 7. Okay? I mean, we could go on all day listing examples. Now, something else I will share. Okay, I said that everything here is a real number, yes? All real numbers fall into one category or the other. All real numbers are either rational or irrational. Okay, so all real numbers, they have to be either rational, so they're can be written as a fraction. They're a decimal that either ends or repeats, or they're irrational. They're the big, long, messy decimals that do not end and do not repeat. Okay? Integers, natural numbers, whole numbers all fall under the category of rational numbers because their numbers are going to be expressed as a fraction. Okay? All vocabulary that's technically been introduced to you before, right? I'm not stupid. I know you don't necessarily remember it, but just review. You need to be familiar with your vocabulary there. Okay. Types of decimals. What do we mean by terminating decimals?
Ones that end.
Ones that end, yes. Give me an example of a terminating decimal?
2.5.
Okay, 2.5. I'll use it. So first of all, I'm going to write terminating decimals. They're the one that ends. So he said 2.5, right? How else could I write 2.5? 2 1/2. How else can I write 2 1/2? 5 over 2. Yes?
Yeah.
Okay. So a terminating decimal is also a decimal that can be written as a fraction. That's my point in there. Okay. You give me any terminating decimal, we can make it into a fraction. Okay. I just went with the one I was given because I could work with it. It wasn't overly complicated. So, okay. What about a repeating decimal? Okay, never ends and repeats, yes? Whether it repeats the same number, or the same set of numbers, right? Do you have an example?
Yeah, ready.
Pi? Does pi repeat?
Don't blame that on me. You're the one that said it first.
Like 1.333333.
Okay, 0.33333333. That's a repeating decimal, yes?
Yeah.
Now, do you know what is 0.333333 as a fraction?
1/3.
It's 1/3. So, I got another one I can give here, but something like 0.3333, okay? It is, yes, it can be written as 0.3 with the repeating bar. We're all familiar with the repeating bar, right? But also, 0.3 repeating, when you have a single digit repeating, Emily said 1/3. I like it, but where I'm going to go first is that it is 3/9. 3/9 just happens to reduce to then 1/3. My point is that, what if I say 0.4 repeating? 0.4 repeating is 4/9. That only works for single digits. Okay, and we could really go into being able to find that and all that, but I just, know the basics. Anyone have a calculator out? I was going to put one more up here just as so you can kind of see. Anyone know what 4/11 is?
Good question. No.
Yeah, the calculator can tell you. I don't think we really.
I have no idea how to use this calculator.
Oh.
The basics are the same.
Okay.
How do we do 4/11 into a decimal?
4 divided by
Jeez.
11.
4 divided by 11. Yes. Doesn't change anything on these calculators.
0.3.
Oh,
636.
Okay. So if it's looking to be 0.3636, so on and so forth, what is that? That's looking to be 0.36 repeating, yes?
Yeah.
Okay, so that's another one. The 2 digits usually, technically, what this would have started off as, 2 digits, this would have been, where do I want to put this? 36 over 99. Okay. Guess what? 36 over 99 reduces to 4/11. Okay. So like a 1 digit repeating is a number over 9. 2 digits repeating ends up being 2 numbers over 99. Guess what 3 digits repeating goes over?
990.
There you go, 999. Okay. There's math behind it that we could do. Nah. Just, random information I'm really sharing. I don't even know if it's necessary, but really the point of that, what's terminating decimal versus a repeating decimal? That's really the point more than anything. Got it? Okay. Good? Okay. Next thing we're going to talk about is interval notation. And I always kind of think, man, have we done interval notation? Have we not? We do. We did it at the beginning of Algebra 2. I'm not sure how much we continued with it or did a whole lot, but my Algebra 2 classes will be doing this right off the bat. Okay, so when we talk about interval notation, it's talking about inequalities. Okay, so our less than, greater than signs. ways to express some of these answers. So when we talk about a close interval or closed interval, we're talking about an interval that has points on either end that are included, as in the dots are filled in, as opposed to what's different about an open interval? The endpoints are open. Now, for labeling purposes, I'm going to call these endpoints A and B. Okay? Now, some information. First of all, as an inequality, okay, so the less than greater than signs, where is this interval? This interval is between points A and B, yes? It is to the left of B, so it's less than B. It's to the right of A, so it is greater than A. Now, technically, those dots are filled in, so it's not just less than and greater than, it's greater than equal to, less than equal to, right? A good way to write this combined, okay, is to say that A is less than or equal to X is less than or equal to B. That's a funky looking B. Okay? And that's just showing, that's just a way to write that the shading is in between points A and B. Okay, those would normally be numbers, but they're points. What changes with an open interval when I write that then?
Or equal to.
Yeah, we drop off the or equal to, right? So it's still going to be less than B, greater than A, which as a compound inequality can be written as A less than X less than B. Now, this isn't even interval notation. This is inequalities. This is what you've been doing for years, right? I don't know if I introduced it in Algebra 2, but I mean, I did introduce it in Algebra 2. I don't know if that was your first time or not. I feel like it might have been. In Algebra 2, we started talking, instead of using endpoints, we started talking about using parentheses, curved parentheses, or
Brackets.
square brackets. Does that sound familiar? Okay. When it was equal to, my endpoints became square brackets. Does this sound familiar? So this is me, you know, like envision, I'm just doing this little snippet. Okay, think of this as that one big long number line, right, that really goes past A and B. I'm just showing that the shading here is from A to B. If it's equal to, we use the brackets. If it's not equal to, we use parentheses. Okay, I'm still calling my endpoints A and B. So that's the difference in how the shading looks, is instead of having the open or closed circles, we have parentheses or brackets. When we express it with inequalities, we also have what is called interval notation. This is the whole point I'm trying to work my way up to, is that this, where does this shading begin? This interval begins at point A, comma, where does this interval end? Point B. The endpoints are included, so we're going to use brackets. So that is the interval notation for this inequality here. When you get to homework, they're going to be asking for interval notation in certain spots. Or if they don't, I do. I don't remember exactly which way the directions work on this one. If it's me asking for them or I do. But I want you doing everything in interval notation, okay? And it might be them asking. I don't remember. I'll have to go back and look. But okay. So what's going to be the difference here? This shading area is from A to B. But what's on either end? Parentheses. Okay. A little bit of vocabulary here. Endpoints, what endpoints were we just talking about? In this case, we use the endpoints A and B, but it's your endpoints, right? Normally numbers. So it's just a little bit of vocabulary. When we talk about a bounded interval, these are bounded intervals because there's boundaries on either end. They don't go on infinitely in either way, do they? They have stopping points. So these are what I would call bounded intervals. So a bounded interval is just any closed or open interval. Falls into the category of bounded. When we get to the back page, we'll do a few examples with interval notation and whatnot. And when we do some examples, that should hopefully, if you're sitting there saying, what is she talking about? Don't stress till we get to examples, okay? Now, if bounded intervals are the ones that have the boundaries, have an endpoint on either end. What's an unbounded interval? One that goes forever either one way, the other way, or both ways. Okay? So they're ones that are going to use infinity, one way or the other. Whether it be it's something that goes to the right and uses positive infinity, or it's something that goes to the left, and if something goes to the left, it's going towards negative infinity, right? Okay. Now, in terms of writing this, let me give you an example here. Trying to think of which way I have this written in my notes. Okay. This is my graph example. We're going to put it in interval notation. And again, we did a little bit of this last year, but it truly has probably been about a full year since, we really talked about it. Okay, so interval notation. You read left to right in America, yes? We read left to right in interval notation. If we go back up to this, when it was a closed interval, we started at A, ended at B. So my interval notation went A to B. Same thing on the open notation. Okay, read left to right with me. This graph here is going where on the left?
Negative.
Negative
Infinity.
infinity, right? Because it's going infinitely left. So we're going to start with negative infinity. Infinities, whether negative or positive, always use parentheses, comma. So that's the left-hand side. It's represented by an arrow going left, so it's negative infinity. What's the right-hand side of this interval? Where does this interval end on the right?
0.
Not at 0. What did I label it?
A.
Oh.
Point A, right? There'd normally be a number. I label it as point A. Point A with a
Bracket.
bracket. Okay? So in other words, if it would be equal to. Now, this uses the word or. I haven't been into the book yet to look this year. So you either use the word or. Do I introduce? You might use the word like a U for union. I don't have any examples in my notes, so I don't remember. Either the word or sometimes you see that U for union. It's not like the U with the stick on it, though. It's just the U part. Now, this second interval, where does it begin at?
B.
Begins at B with a parenthesis, comma. Where does this interval end at? Positive infinity, because it's going off to the right, and infinities always use
Bracket. Parentheses.
parentheses.
I was thinking parentheses, but I called it bracket.
It really just matters, in this case, of what you write down.
Yeah.
You know. Okay. As I said, when we get to the backside, we'll talk a little bit more into this, okay? But that gets you some of the, I hope that was a little bit of review, maybe? I know. It's been a bit. I get it. Okay, before we move to the backside, though, let's talk about a couple of decimals. Determine if the following decimals repeat or terminate after finding the decimal form. Now, if you don't have a calculator with you and you want to grab one real quick, you can grab one from here and see if you can figure out anything on it.
Do you like wanting us to write the decimal answer down, or like?
We're going to write the decimal answer down, and then we're also going to answer the question.
Okay.
Okay?
Is this her microphone?
Almost.
I
Okay,
target.
so I don't know. There's an on button somewhere. I don't even know where. On button, bottom left. And if you get some kind of message, why am I getting this message? Okay, the basics. Guys, this is a normal calculator. It has a lot of fancy stuff on it, but 1/16. What are you finding out about 1/16? What are you going to tell me, Brody?
Oh, I was gonna say it's a terminating decimal.
Terminating decimal, because what is the decimal form of 1/16?
0.0625.
Okay, and he got that reminder by
1 divided by 16.
1 divided by 16, right? I expect you guys to know this. You're pre-calc, but I also understand we need reminders, right? So 1/16, when you divide it out, is 0.0625, did you say?
Yeah.
I should know that one, but I'm just. And can we agree with Brody it terminates?
Yep.
Okay. Pretty obvious one. Goes a couple of decimal places, it ends, you can tell. What about 55/27ths?
It repeats.
You think it repeats?
Yeah.
What are we getting?
2.037037037.
So, fairly obvious that it's a repeating decimal with 3, you know. So that one repeats. Okay. What about C?
It,
Terminating.
yeah, it ends and it never repeats. That's just.
It's a long decimal.
Undefined. Yeah.
Your options are repeat or terminate. Your options are not undefined.
Terminate.
Terminate.
Wrong.
Oh, it is repeat. So how many decimal places can you go before?
Okay, so, and this is a difficult one because the calculator doesn't really tell you, does it? Now, notice, as long as that decimal is on your calculator, right, you're looking at it. That's kind of the extent of how far a decimal goes on the calculator, okay? You guys know as well as I do, it doesn't just end just because it ends on that screen, right? Decimals sometimes go past the end of the screen. You guys know that. You've been around, you've used calculators, okay? So this is a scenario where it's a weird one because if you have to pick, like I would probably pick, if I didn't know better, I would pick that it's irrational. It goes on like pi. But that's not one of my choices here. I asked you, does it repeat or does it terminate? So it either ends at that point, or some point, or it repeats. Could you have, I don't know how many digits we have there, like 10 digits and then it repeats? You can. Now, how would we verify this? I'm going to be nice, we're not going to verify it, but how would you find out that it repeats?
2 8s.
By hand, via long division.
Oh.
We're not doing that. You're just going to take my word on it.
Yeah.
Okay? You want to do it, you have fun on your own.
I started sweating.
As a class, no. So I'm going to write down that according to what I have, it's there's a 0 there, isn't there? 5, 8, 8, 2, 3, 5, 2, 9, 4. That's what your calculator shares, right? Again, I'm not making you prove it. We're just going to take my word. It repeats via long division. Okay? So you get bored later today. There you go.
I'll be thinking about perimeter later.
Yeah, we're gonna be running perimeter. Brody's gonna be like trying to figure it out.
Oh no.
Maybe Coach will forget.
Hopefully.
My screen on my calculator started getting dark, and I thought it was a phone, and I clicked on the screen.
They are not touchscreen.
Yeah.
They are not touchscreen.
Saturday.
Okay, 14, right? Okay. Sorry, I have to adjust to what time does pre-calc end.
I found
Is it a different hour
Those are
now?
math one here.
Yeah. Okay. Ready for the back? And what I'll say, okay, guys, so calculators, and I don't know what calculator you picked up today. I don't care what calculator you picked up today. But they're going to be the same numbers as to what you have back there. So Brody, even though it appears he has his own calculator, I'm still going to assign him number 1. And I'll put little tags on there that have your name so you can, easily grab.
Oh yeah, 'cause
But-
we're the only pre-calc class.
You're the only pre-calc class, yeah. I'll give my calc kids a couple of others down later on, but, you're welcome to pick that calculator. You don't have to wait for me to say, you have my permission. You don't need my permission to go grab your calculator,
How many
okay? So,
calc kids do you have this year?
2.
2? Who are they?
Eli and Sergeant.
Wow. I bet that's a fun class.
it's different, that's for sure. Okay. Moving on. Let's try and get at least some of this backside in here.
So we have to.
Yep.
Okay.
Okay. Describe and graph the interval of real numbers for the inequalities. Now, graph, you know what I mean by graph. We're going to put it on a number line. Describe, when you see describe, and you're going to see this a little bit in homework, I'm looking for words here. The part you guys don't like about math usually, but I'm looking for words. So I'm not going to read what that is, because then I'm giving it away in terms of, how you read that inequality. But in words, what do you think that represents?
That 3 is greater than x is greater than 0.
Is that backwards? X is less
Okay.
than
I mean, we read it as x is less than 3, right? But what does x is less than 3 mean?
It's an open circle with a line, and it's going to 3.
So it's any number less than 3.
Okay. Any number less than 3?
Yeah.
Okay. X represents just a generic, an unknown, right? So X represents whatever number. So I have mine written as real numbers less than 3, if we want to get the mathematical word in there instead of just any number. But this is real numbers less than 3.
Sixth grade, please report to the bookstore to get your iPad.
Now, we could argue that 3 should be written out in words, but, Okay, now, graphing it. Okay, so, here's what I'm going to do. You got a blank number line. What kind of label should be on your number line?
0, 1, 2,
Not A and B this time.
0, 1, 2, 3, and 0, negative 1.
Okay. What is a number that has to be on the number line?
3.
3 has to be there, yes?
Yeah.
Now, with it 3 being on there, I wouldn't necessarily go to the negatives.
Okay.
My ruling is I like to see a couple of numbers on either side. Okay, so I would be fine. Yeah, if I look at my key, I have 1, 2, 3, 4, 5 because I put 2 numbers on either side. Okay, 0, 1, 2, 3, 4. That would work, but just some numbers around it. Now, am I saying that if Brody put negatives, he's going to be wrong? No. I'm just,
Yes.
Okay. Now, how do we graph this?
Is it an open circle? Is it like open circle at 1, somewhere, and then to 3, an open circle? I forget where the other point
Is it open
There's
circle?
brackets.
Is it a closed circle on 3 and then just an arrow going the other direction?
I agree with the arrow going this direction. Wait, hold on, let me
I
check.
feel like it's an open circle because there's no equal to.
It's less than 3 though, so it can't be 3. Right?
It'd be open circle. Open circle with an arrow going.
What if I say it's no type of circle?
What?
Because we're doing interval notation.
It's just a dot.
So your choice is a parenthesis or a bracket as opposed to an open or closed circle.
Let's go.
There's a trick question.
Yes. Okay. So this is real numbers less than 3. So you guys had the idea it's you're shading left of 3, right? Whether you draw a line or, the other option is what? Some type of shading left of 3. 3 is the number they give me, so that's a starting number. Prior to me, we would have used an open circle. Okay, because it's not equal to, we would have used an open circle, as in a not filled in circle. Because I'm trying to transition you to interval notation, we're going to use a parenthesis instead. And the parenthesis opens the direction of the shading. Are we good now? Okay. So you kind of know it. It's just, putting it all together. Okay, B.
It's because
Thoughts on words first.
so any real number between -1 and 4?
Real number greater than 1 but less than
Less than
or equal to 4.
I like both ideas. Okay. The only thing, and I'll be honest, I have actually kind of what Brody has, but I have a little bit of an extension on there. Okay, I agree it is numbers that are less than or equal to 4 and greater than -1. That does make it numbers that are between -1 and 4. Now, what's happening at -1? Is -1 included or excluded? It's excluded because it's not equal to. What's happening at 4? Is 4 included or excluded?
Included.
It's included because it's equal to. Okay, so what I have written on mine, real numbers between -1 and 4, excluding -1 and including 4. I know it's a lot, but
So if we were to write it like real numbers greater than -1 and less than or equal to 4, does that still work? Like if we still say it's like less than this one's equal to, what do we
I mean,
need to
it's
have?
not wrong. I just, in describe, I'm kind of looking for you to not just
Not
translate it.
say
Does that make sense?
Yeah.
Because I feel like you're just kind of translating it into words or just you're reading it. I'm looking for a little bit more of a description. So, you know. So real numbers between -1 and 4, we're going to say excluding -1 and including 4. Okay, what about a graph?
We need numbers to like -2 or 3 and 5.
Okay. We have to have -1 and 4 on there. I would appreciate it if you go at least one number past. Okay. So if we go -2, -1, 0, 1, 2, 3, 4, 5. That fits perfect on mine. Where's the shading?
-1 and 4.
Okay. So I am shading from -1 to 4. What's at -1?
Parentheses.
Okay, parentheses is not equal. The parenthesis opens towards the shading. And what's it for?
A bracket.
And it opens towards the shading. Okay? And as much as I'd like to keep going, that's a good stopping point so we don't get caught in the middle of anything. Okay, so we'll pick up here tomorrow. I would say, yeah, we have a few notes to get through because this one is there is a third page to this lesson. Okay, so we have a few notes to get through, but I would like to think you'll have a little bit of work time at the end too. So bring your book with you. If I get organized, so I don't have the Schoology site set up yet. Okay, I'm just behind. I haven't gotten everything imported into the Schoology site. If I get that set up, I might be able to show you the online book tomorrow. There's an if. If not, you'll have to suck it up and use the hardback book and, you know.